For the longest time, the race in AI has been all about one thing: size. The bigger the model, the smarter it got. Simple as that. But that whole era, it's coming to an end. It feels like we've finally hit a wall, a scaling wall. And the new frontier, the really exciting stuff, isn't about making AI bigger. It's about making it totally, fundamentally different. So let's break down what that really means.
So here's the big puzzle we're going to tackle. We are building these absolutely massive AI models with trillions of parameters, but they still get tripped up by complex multi-step reasoning. How is that possible? They can know almost anything, sure, but can they actually think? This is all about why we're seeing this huge shift in how we even approach building intelligent machines. The old rule was just so beautifully simple, wasn't it? It was a predictable recipe you could count on. You just throw in more data, more computing power, more parameters, and bam, you get a better AI. This was the pure scaling hypothesis. And look, it got us a long way. It took us from clunky bots to models that feel genuinely conversational. But that straight, predictable road is starting to look more and more like a dead end. And this right here is the scaling paradox in a nutshell. Look, making models bigger is fantastic for their knowledge base, their ability to store and spit back facts. That bar is way up there. But the gains in actual reasoning, they're much, much smaller. We're getting these diminishing returns. It's like we're building these incredible digital encyclopedias. But what we're really struggling to build is a genuine problem solver.
So what this paradox is really telling us is that an era is ending. We're seeing this fundamental pivot away from just brute force scaling and a turn towards smarter, more elegant architectural design.
Okay, so if elegant design is the new name of the game, what does that actually look like? Well, researchers are digging into this really revolutionary idea, something they call the ghost in the machine, and it's all about creating a dedicated logic core.
Andrej Karpathy put this idea into words so powerfully, he basically argued that the gigantic size of today's models is because of what he called knowledge pollution. They're wasting almost all of their brain power just memorizing the internet, when the real pure algorithms of thought could be, well, a whole lot smaller. 1 billion parameters. Just think about that for a second. The models we're using right now are hitting 70 billion, 100 billion, even a trillion parameters. Karpathy's idea suggests that the actual thinking part, the cognitive engine, could be incredibly small and super efficient, like a tiny, powerful ghost running the show inside this vast, sprawling library.
So here's the absolute key. The logic core is an architecturally separate piece. This is a clean break from the old way of building one giant monolithic model. The new thinking is all about decoupling intelligence, which is all about processing, from knowledge, which is really just storage.
And there's a really great way to think about this. The old approach, the monolithic model, it's like a student who just crams and memorizes the entire textbook word for word. Sure, they can recall facts, but they don't really get the concepts. The new way with a logic core is like a student who deeply understands the core principles and just knows how to look things up in the library when they need a specific fact. That's the game changer.
All right, so a brain in 2 parts sounds pretty cool, but how does an AI with separate components actually work? To get that, we need to look at how this cognitive decoupling is put into practice.
What researchers are doing is modeling this on human cognition, using a kind of dual system approach. So phase 1 is fast thinking. This is where the lower layers of the neural net just quickly pull up all the relevant knowledge. Think of it as your intuition, your gut reaction. Then comes phase 2, slow thinking. This is where the deeper, more powerful layers take that raw information and start to logically refine it, correct it, and really think it through.
But why go to all this trouble? Why is this separation so critical? Well, because there's a massive danger with the old all-in-one approach. When you try to teach a model new, specific stuff, it's a process called fine-tuning, you run a huge risk of overriding its fundamental ability to reason. It literally gets smarter about one thing by getting dumber at everything else.
And this isn't just a theory. You could see it in the data. They call it reasoning collapse. So look here. The COT, or chain of thought accuracy, which is just a measure of its logical, step-by-step thinking, it actually drops after fine-tuning. And faithfulness, basically whether its reasoning makes any sense for the answer it gives, that plummets. This is exactly why you have to protect that reasoning core, keep it separate, keep it stable.
Okay, so this whole architectural shift, it opens up an even deeper, more profound question. If an AI can separate its knowledge from its reasoning, does it even need to use human language to structure its thoughts? Right now, most of our best AIs use a chain of thought. They basically talk themselves through a problem step by step, in English. But that's slow, it's inefficient, and worse, once it writes down a single bad step, it's kind of committed to that flawed path. The alternative is something called latent reasoning, where the AI does its thinking in a pure abstract concept space, letting it explore multiple possible paths all at the same time.
Latent reasoning is basically a machine's native stream of consciousness. Instead of having to translate its thoughts into clunky human words, it keeps them as these complex mathematical vectors. This allows for this incredible superposition of thought, where it can hold multiple, even competing ideas in its mind at once before it decides on a final answer. It's thinking at the speed of math, not the speed of language.
So where is all of this heading? When you put it all together, a decoupled architecture, this new way of thinking without words, you completely unleash the potential of the logic core. So let's look at what this new type of AI could actually do.
This is really the end goal, a disembodied reasoning engine. It's independent from a giant internal knowledge base, so it can't collapse. It's independent from the slow, clunky limits of human language, making it super efficient. It's natively multimodal, which is huge, meaning it can reason directly about images, sounds, and video without having to translate them into text first. And finally, it has what researchers are calling thermodynamic stability, which in plain English means it knows how hard a problem is and it can assign just the right amount of brainpower to solve it without wasting energy or getting stuck in a loop.
So the ultimate payoff here isn't just a slightly better chatbot. It's a completely new kind of AI. One that's more stable, way more efficient, and can actually understand and reason about our complex, multimodal world in its native format. It's a shift from a language model to a true world model.
And that leaves us with one last, really provocative thought. For all of human history, our intelligence has been tied to knowledge, to the library, to the books. But what happens when we finally build a pure reasoning engine, an intelligence that doesn't need to know things, but simply knows how to think? What does that future even look like?